Finally, our software successfully runs in production. It has a beautiful design and we have invested a lot to make it simple, clean and beautiful. And then it happens. A requirement change demands a variation point which was not foreseen in the design. As we haven't touched the project for a while, we neither remember exactly every little detail of the implementation nor how high the test coverage was. So one thing becomes pretty clear immediately. We need a systematic refactoring approach to minimize the risk of unwanted side effects. Let's explore the power of such refactoring techniques. The project the change was requested for is called WXS bot. WXS files are used to describe the content of an MSI package. The WXS bot automatically generates such WXS files containing assemblies and configuration files found in Visual Studio projects following certain conventions. The project follows basically an architecture structure. We have a CLI project, which contains the command line interface. We have a core project, which contains the entities and the use case interactors. We have a gateways project for all the adapters between the use case interactors and the outer world. Of course, we also have some tests, and we have a test development kit, TDK, which is about test abstractions. Looking into the domain, we see Visual Studio Solution, Visual Studio Project, assemblies, and content files. And we have a concept called bundle. Bundles are nothing but top-level folders with their own Visual Studio solution, which are used in bigger code bases to structure those code bases. The basic workflow is the following. From the command line interface, we call a command. This command first resolves the bundles from a given wildcard, for example, and then calls the interactor, which collects all the Visual Studio projects from the Visual Studio solutions, loads those, builds up a WXS document with assemblies and content files, which are configuration files. These documents are finally returned to the command, which then writes those files into the file system and may add them to the version control system if needed. Along the way, warnings and errors are reported to the user to the console. The variation point we have to introduce into the WXS bot is the support for the old legacy Visual Studio project structure, which is this, to the new one, which is this. The key difference between these two Visual Studio project formats from perspective of the WXS bot is the XML namespace. While the old format had an XML namespace, the new format doesn't have any. One more relevant difference with the new format is that a lot of properties no longer have to be specified explicitly because they are automatically set based on conventions. So we have to read both formats really in a different way. Before jumping into code, let's think about the approach. The classic approach would be to add a proper test safety net and then change the code and use the test safety net to ensure that there are no unwanted side effects. While having a good test safety net is definitely a good advice, we will have tests in this project as well, we want to focus on a systematic approach which has two key aspects. First, we will use refactoring steps which have to be, by definition, behavioral non-breaking. Second, we will focus on a stepwise approach where every single step is just one logical step and is that simple that even a code review can prove that it is a behavioral non-breaking code transformation. This way we address potential test gaps, and hey, which software doesn't have any test gaps, and produce a traceable protocol of our changes, which is the source control system history, which can then later be used for analysis in case some issue slips through. So our approach looks like that. We change something, we compile it, we test, we review our code before check-in, we finally do the check-in, and start again. We start by locating the code which is dealing with the Visual Studio project files. Following the clean architecture, our entity Visual Studio project does not know anything about Visual Studio files and their XML format. Such code we will either find in the frameworks layer or in the gateways layer. In this project, we will find it in the gateways layer, and this is the Visual Studio project loader. This loader deals with all the XML reading. As we will have two loaders in the end, we start with renaming this loader to Legacy VS Project Loader. We intentionally do this compile breaking and without the help of the IDE so that we are sure that we really find all the occurrences of the old loader. So once changed the class name, of course we need to change here the usage of the name as well. Now we also make this class internal so that it cannot be used directly outside this project. And we also add a factory to be able to create an instance of that class. So we go here and say create new file, yes, project loader factory. Let's add a namespace wxs bot gateways, and we add a class public class vs project loader factory, and we simply provide one API ivs project loader create, and we just return a new legacy Visual Studio project loader. Now let's compile the project and let's see which other places we have to adapt. Of course, in the program, we now have to use our factory. Let's close this here. So we create here our factory, var factory, new vs project loader factory. And then instead of instantiating the loader here, we call factory.create. And the same at the second place. And one more finding in the test API. And here we will do the same. Var factory, new vs project loader factory, and we use the factory to create the loader. Let's compile again. No more problems. Now let's run the tests. All passed. Now we would review carefully all our changes, that we really only submit what we really intend to submit, and submit the changes into the version control system. So with this change, the existing code which deals with Visual Studio project files is pretty isolated and hidden behind a factory. So when we later introduce the other loader for the new Visual Studio project file format, we know that we only have to change this part of the code base and will not have any impact on the rest of the code base. In the next step, we will apply the same idea to the fake implementations used in the tests. So let's go into this TDK, and here we will find the C# project, which builds up one of the legacy Visual Studio project files. And we see it's also dealing with this namespace. So let's rename that class to legacy C# project. Of course, we have to rename the constructor as well. And in this creator, we also have to use the new name. And now we realize that this project doesn't have an interface yet. So we need to create one. Okay, so let's add a new file here. C# project. So here's the interface I prepared in order to keep the video short. And now we use the interface instead. So we will return the interface here. And of course, we have to make our class implementing that interface. There's one more error. Let's move on to the content file, which will now also deal with the interface instead. One more place. One more. Okay, let's compile the project and see whether there's anything else to be adapted. Okay, a few more places. Let's just do copy and paste. Here's one more place. And of course, this does not work with the interface. So let's keep this open here for a second. One more. Okay, what do we do with this one? We apply the same principle as in the previous step. We create a factory, which is used across the code base to create an instance of a C# project object. So let's add here the factory, create file, C# project factory, and we create a factory class public class C# project factory, which has just one simple interface, create, which returns an instance of the legacy C# project. Okay, we don't use the constructor here, but the create method. So this needs some parameters, and we just copy them from here over here. Add some usings. And we need to forward the parameters, of course. Reformat the code. And here's our factory. Of course, we should later check whether this create function here is actually still needed. There seems to be still an error. Let's see. Right, now in this bundle, we have to use the factory. So we just type here, factory. We need to instantiate it, of course. Let's compile everything. And succeeded. Of course, we would now run all our test cases again, and if they are green, we would carefully again review the changes we made and submit the changes to the version control system. Now we have also isolated the fake implementation needed for the tests, and we have hidden it behind a factory, so that again, if we later add the other implementation, we just have to take care of this one part of the code base. In the next step, we will simply create a copy of the legacy Visual Studio Project loader and adapt it so that it can deal with a new SDK style project format. So let's do this. Let's create a copy. Let's rename the copy to SDK style VS Project loader. Of course, we have to adapt the class as well. SDK style VS Project loader, and here as well. Of course, we would now make all the necessary changes to support the new SDK style Visual Studio Project format. For now, to keep the video short, I would just remove the namespace, the XML namespace, and leave the other changes for later. So let's just replace this here with nothing. Okay, and we are basically done. Of course, this loader also needs tests. So we go into the test project and repeat the same here. We create a copy and we rename the copy to SDK style VS Project loader tests. And we will rename the class as well, of course, into SDK style VS Project loader tests. Of course, up to this point, neither the production code nor the test code deals with the new project style already. We haven't wired up the SDK style project loader with the factory, and also the test does not yet create these style of projects. Still, let's run all those tests to ensure that those are still green. Okay, passed. Let's continue on the tests and copy the legacy C# project. Create a copy and rename it to SDK style C# project. Let's rename the class SDK style C# project and also the creator here. And now let's also ensure that this one creates these new SDK style projects Of course, there would be a few more changes necessary than just the XML namespace, but again, let's just focus on that one to keep the video short. Okay, we can do here search and replace as well. Replace all. Okay, a few more cases. Here the namespace is no longer needed. Also here and here it can be removed. Okay, now we can create these new SDK style projects for our tests. Looking at the tests, we see that we don't create these projects directly, but that we use a class called workspace, and there we create a bundle, and then within the bundle we can create projects. For the sake of simplicity, we decide that we introduce here a new parameter which indicates which style of project we want to use within that bundle. Bool use SDK style projects. And this one we now pass here on to the bundle. Bool use SDK style projects. We will remember this in a property. Okay, pass it to the constructor. Bool parameter. And then we assign it to the property. This might not be the nicest solution, but well, we are here in test code, and for now I think it's sufficient. Okay, let's go back to the test. If we have this bundle, we again go to the workspace to create a project, but this workspace then goes to the bundle to create the project. And here we see our factory again. So let's pass this property also to the factory. And now the factory requires a constructor. I like to use my. Okay. And now if my use SDK style projects is set to true, then we return SDK style project create, else we create the legacy one. Of course, the parameters are the same. Let's go back to the tests. Again, we make this a compile breaking change to now force us to inspect each and every call of create bundle and to decide explicitly whether we pass true or false for this use SDK style projects. Here we are in the SDK style VS project loader, so we pass true. And we copy this on for the rest of these tests. And a few more. And now let's go to the legacy VS project loader tests. Here we of course also have to specify which projects we want, and in this case we pass false. And we fix all the occurrences. If we now run all the tests, the SDK style VS project loader test should be red, because the tests now use the SDK style projects, but still the production code, the factory, is not yet adapted to instantiate the proper loader. And as expected, the legacy VS project loader tests are green, the new ones are red. To make these tests green, we now also have to adapt our factory in the production code. So let's go to the VS project loader factory and add the creation of the new SDK style projects. Looking at the factory, we realize that there is no way to detect which loader we should actually create. If we look at the loader interface, we realize that only once we have the path to a project, we then have a chance to detect whether we need to load it with the legacy VS project loader or with the new SDK style VS project loader. So what we will do here is we will introduce an adapter, class VS project loader adapter, which also implements the interface IVS project loader. and we will return this instead as project loader adapter. And now in this adapter, we get the project and we have a chance to detect which loader is needed. And we do this by inspecting the project itself. So we load the project using xlinkq. Let's add the namespace, load project path. And if the root element has an attribute called SDK, then we know that this is an SDK style project, so we use the SDK style Visual Studio project loader, else we use the legacy loader, of course, to load the project. And with this simple trick, we can keep the decision within the factory which loader is needed and can automatically detect the proper implementation. So let's run the tests again. Oops, still red. We forgot something. In the new SDK style C# project, our fake implementation, we didn't adapt the root element to set the SDK attribute. So let's fix this. New attribute SDK, and the value will be Microsoft.net.SDK. Let's run the tests again. And green. Now we have successfully introduced the variation into our existing design, into our existing code base. We have minimal changes due to the usage of the factory pattern. We have done it step by step. So now if we look into our version control system history, we have a nice protocol of all the changes we made. We kept all these changes, all the steps very simple. We made some steps intentionally compile breaking so that the compiler can help us finding all the code places which we need to adapt. And we will now review these changes carefully as well and submit them to the version control system. As a last step, we could now check the code we have copied, whether we can do any refactoring here. Maybe we can extract some code and use it in both implementations. Maybe even a base class makes sense. For this video, we will skip this step. That's all for today. We have seen that when following a systematic approach and basic refactoring techniques, we can add a variation point easily, even to a legacy code base, without impact. See you in the next video.